All right, good evening, everyone. We're gonna get the show on the road here. So welcome to ASRC Whiteface Mountain Field Station. This is our second lecture in the Falconer series this summer. And tonight we have Robert Haynes, meteorologist from the National Weather Service office in Burlington. A couple quick notes. We'd ask you to please hold your questions to the end. And anyone that has a Zoom question, just please put it in the chat. The restrooms are downstairs. The exits are where you came in and down at the north end of the building. Yeah, I guess that's it. So without further ado, we'll welcome Robert.
How are people with the lighting? Would you like lighting up, or are we going to try and see how? Yeah, better. Here's one in the back. Okay, a little better. You got a little spelling around this. Perfect. Okay, great. Go ahead.
All right, good evening, everyone. Thanks for coming out. My name is Robert Haynes, and I'm with the National Weather Service in Burlington. As you might just catch, my accent is not from around here. I'm originally from Atlanta, Georgia, but I've been here for about 6.5 years now. And so it's great to be able to come and present this evening. Last time I came was about 5 years ago. And so it's nice to be able to come back. This is, I think, the first time we've done this since that last time we came 5 years ago. So let's hop right in. I'm mostly going to present information on winter and the fall season. I think that's what most of the area is most interested in. But let's hop into a little bit about what we do. We'll provide a little bit of an introduction about who exactly we are at the National Weather Service. There are often a lot of questions like, oh, are you associated with the Weather Channel? Or do you talk with those guys over at the TV news stations? And really, we're a part of the federal government, so we kind of tend to work a little bit more on our own. We'll describe what our warning services is like, and then a little bit on our decision support services and how you can kind of figure out the resources to help you and the winter seasons, as well as some information about heat, and the school information is not necessarily relevant to this, but so let's look a little bit about what the National Weather Service is at a glance. We have 168 operational units. When we break that down into the specific forecast offices, there are about 122 of us across the United States, including in areas like Guam and American Samoa at Pago Pago. So we're spread out a lot between the country, as well as areas that we established bases on in World War II. Within the National Weather Service, there are about 4,500 employees. And 86%, that would be like the field offices. Those are the forecast offices. So people like me. We issue about 1.5 million forecasts and 50,000 warnings per year. So we stay pretty busy over the year. There's a lot that we have to do and a lot that we watch for. But as far as how much the American taxpayer puts into the National Weather Service's budget, is roughly $3.83. So your tax money goes, that portion of your tax money covers us. And so our goal is to be able to provide any kind of water, weather, climate data. We quality check it, and then we provide forecasts for users to be able to make decisions about whether or not you can go outside, or if you want to take a nice trip on the lake, figure out whether or not that may be the decision for the day that you want to make. And so we cover the whole U.S. As well as several of our waterways. We're divided up into specific regions here, and each region covers a geographical area of some of the weather patterns to that area. And so the eastern region, which is where we're under, covers most of the Ohio River Valley, as well as the I-95 corridor down to the Carolinas. But we're nestled all the way up here against the Canadian border. And so we're pretty far removed from a lot of the other Eastern region offices, but we're covered by the River Forecast Center as well. That's here in Boston. And you can see there are all kinds of different national centers. And you might ask yourself, like, why is the National Center for, like, the National Weather Service headquarters? Why is the Space Environment Center, the Aviation Weather Center, and the Storm Prediction Center, why are they all in different places? Well, part of that's going to be because you want to avoid, if there's one area that may, say, suffer a terrorist attack, that some other spot can take over from those responsibilities. So part of the reason why we're spread out across the country is, one, to understand our local regional weather, but two, to be able to back each other up. And so if for whatever reason there's some kind of outage that takes out the National Weather Service in Albany, we'll take over and cover for their weather forecasts until they can get back up and running again. And if all else fails, we have National Weather Service in Caribou to help us out and us to help them out as well. We are primarily the state liaison office for Vermont. So whenever we're coordinating with state governments, sometimes we just kind of have a no changes here or what Albany said kind of function whenever we do calls. So primarily whenever there is our briefings with the state government, it's going to be the National Weather Service in Albany that will be providing a lot of the forecast information to your state and local officials, as they are the state liaison for New York. And so here's a look at what we do. I think a lot of people kind of think that we as meteorologists at the National Weather Service are stuck to one thing, but really our job changes every day. And that's one of the reasons why our job, I think, is very fresh and unique compared to some of the other kinds of meteorology jobs that are out there. So in addition to the public forecasts and the aviation type work that we do, oftentimes we do outreach events like this where we come out and do these presentations. We also do research. We have teams that go out and take snow cores and go and look out at river ice. So recently we began also surveying the river ice here in the state of New York, at least our 4 northernmost counties here, because that's relevant to ice jams. But we cover all kinds of different tasks and duties, and we work with media partners as well, just to establish the network of communications that helps make the work that we do and the work that we provide to you as beneficial as possible. It's really a community effort as far as the work that we're able to do with you. And so it's really helpful when we have the chance to come out and present to you to build our relationships. So what is weather forecasting like? What exactly is the picture of the forecast? A lot of times we have people ask questions like, hey, we noticed the forecast 4 days ago and the forecast today is very different. And so why does that happen? Well, you know that's an image of the Mona Lisa right there. It's low resolution, but you can make out the fact that this is the Mona Lisa. Like, sure, the iconic smile, a little tough to see. And a lot of the details on the hand and the background are not perfectly clear, but you know that's the Mona Lisa. So for us dealing with long-range weather models that are greater than 4 days out, it's a lot like this. We know the general picture of how things are going to play out, but there's some missing details. There's some things that are difficult to discern because the low resolution models that take that time 4 days and beyond look a little bit square sometimes. So often we sort through different models. We call this an ensemble forecast. When we look through different models and get some of the details, we can see like some models show the same picture. Like with this one, like the hands are clearly contrasted with their white versus black squares. Whereas this one, it's a muddy picture that's really hard to define and determine. But as you get closer within 48 hours, you can start getting clearer pictures of what's going to happen. However, with higher resolution models, sometimes things get a little squirrely. And so sometimes we're dealing with, when we get to this 2-day time frame, we're starting to see things that may perplex us, may challenge us. But ultimately, when things turn out just right, we have a very nice, crisp picture, very minute details when we get especially within that 48-hour time range. And of course, when we're dealing with difficult terrain, that can sometimes make this a little bit more challenging because models like this may not be able to resolve mountaintops like Whiteface as efficiently as a mesoscale model that can highlight some of those minute details. And so we really do rely on like the high res models. Like, so sometimes when we kind of say like, yeah, they're going to be pop-up thunderstorms, but we're not really sure how things are going to play out, especially 3 to 5 days out. Part of the reason is we're waiting for that 48-hour time to get the clearest picture that we can get. And so these forecasts that we issue, it's really only the beginning. As I've alluded to, our network across the United States and everything that we do means nothing if we cannot communicate the forecast to you. So being able to come out and talk this evening is one way in which you can kind of talk with us and learn a little bit about what we're about, and also reach you and some of your questions as well. So a forecast, it can be as great as it can possibly be, but if you don't understand that forecast, then that forecast is no good. And so we want to be able to interact with our public and help your understanding so that when we do make a perfect forecast, you can take the proper actions. Snowfall forecast of 4 to 8 inches does not mean as much as the idea that, okay, this 4 to 8 inches is not just 4 to 8 inches, but it's 4 to 8 inches of heavy, wet snow. And so that idea of there being power outage potential is something that we may add in these kind of decision support type services, trying to indicate, all right, we have this forecast. What is it going to mean for the day-to-day individual? And so with that, we then can start briefing to our partners saying like, all right, we have heavy wet snow or extreme wind chills or these other type of situational awareness type calls. And from there, we can then help the state and local officials in our government, or you, if you happen to see them on social media or reading on our webpage, you can pass that information along so that when that comes to that point, you can make the decisions that you need to make, enact any weather plans that you have in case of those type of emergency situations. And from there, if need be, those recovery efforts. So as far as our timeline of things, oftentimes the general public is mostly going to interact with us between this watch and this warning phase here. We're starting off, we sometimes start briefings with state and local partners as early as 3 days in advance, especially if it's a weekend and we know that people might not be in their office on a Saturday, Sunday. Sometimes we'll start things very early, but usually we'll trigger our watch warning process and communications to start sending those emails and those briefs in those phases. And so I think it's important to highlight the distinction between a watch and a warning. So as a reminder, a watch, whenever we discuss watches, indicate that ingredients are coming together and there's increasing certainty in a specific weather event about to happen. And the warning phase is when the ingredients are there, it's imminent that this event is about to take place. So it's a very gradual buildup that we take as our approach to messaging the forecast. And of course, for the mountaineers and the skiers, we have plenty of information that you can receive on our recreational forecast page. If you're not familiar with our recreational forecast page, aside from even just the basic information that you can find regarding the mountains and the lakes, a lot of times we now even have, especially on the Vermont side, we've been working with the state to put up these QR codes on kiosks that take people directly to this page. But these are some of the things that we're kind of doing to help spread the message of our recreational forecasts. And if you've ever looked, we have at the higher summits, a lot of our points are clickable. And you can get the hourly forecast charts at that mountain summit to get a little bit more specific information about which summit you're interested in. And that can give you a little bit more detail than, say, if you clicked a spot more local into town or simply typed in the name of the city. And specific to Lake Champlain, we also have high resolution maps that are made to kind of highlight the waves as well as the wind forecast in that area. So I think if you click the lake map on our recreational page, it'll take you to this high resolution chart that helps you to see the wind and the waves. All right, so let's start diving into a little bit more of some of the forecast aspects of things. Winter weather, especially here in the northeastern United States, is fairly complex and challenging. To the west of the Adirondacks, you have Lake Ontario, where a lot of lake effect snow rides upslope across the mountains. And that upslope snow helps to, that upslope flow into the mountains helps to produce snow. And from there, it's a very tough balance between the speed of that wind and how much the atmosphere is going to let that wind come up over the mountain slopes that determines winners and losers in lake effect snow events. But then of course, you also have nor'easters, for which the Adirondacks are often a little far removed from the coastline. So receiving nor'easter type events can be a little challenging here. And so the terrain and just small subtle shifts in a low pressure track can drastically change the outlook of the speed of the winds here and how much heavy snow can be received in this area. The complexity in low tracks, just where the greatest impact often leans in on whether an area of low pressure is going to track around 40 north latitude and 70 west longitude. So if you ever you hear like a meteorologist throw out the term the 40-70 benchmark, they're referring to that specific latitude longitude point. One of our old bosses, his saying was, "Where is the low tracking?" And that's one of the biggest indicators for what type of impacts you're going to receive from snow. So for areas like the Adirondacks, a track towards Long Island, New York, is going to be one of the most favorable configurations for heavy snow here in the Adirondack Mountains. Lesser impacts following this blue line here. Typically less snow. You may still have some of that heavier wet snow and maybe in southern Vermont, but generally when it tracks right over the 40-70 benchmark, the impacts are going to be a little bit more minimal. We're just a little too far from the moisture source. And by the time it's east or south of the 40-70 benchmark, it's a little tougher to get snow. We sometimes have too much dry air from high pressure, but sometimes that means we have some of our most beautiful weather conditions when that tracks just to the southeast. Sometimes we have complex cases. Sometimes you'll hear the kind of jargony slang term of a double barrel low. And what that kind of means is a little bit more about what this was trying to show here, where a low pressure system rides out in the Great Lakes, where you have a second area of low pressure developing off the Carolina coastline. And they can have some tricky interactions that sometimes result in the warm front from the parent low decaying well before it makes it to the Adirondacks, or sometimes it remains the dominant force and produces a lot of snow, only for this to then come up and then produce even more snow, sometimes in waves that are 4 to 6 hours apart. And so these make it tricky because you'll get snow and then you'll have nothing. And you think, okay, everything's good. And then you start going out and then you get the next wave of snow. So when we are dealing with two separate lows coming from the Great Lakes and then the coastline, can be very challenging. And of course, one of the recent storms that have really solidified themselves in the base of our climate is the Pi Day storm in 2017. It'll be probably a long time before this particular storm is bested. And so a lot of the decision support services that we provide and a lot of the ways we communicate, we're just affected by how significant this storm is. A lot of meteorologists talk about rapid intensification of things like hurricanes. Same kind of thing can happen with extratropical winter systems. Sometimes the term bombogenesis is thrown around. But the idea of the lower the pressure of your winter storm, the more likely it is to drive heavy snow and strong winds. And so this particular storm, when you're starting to get into the realm of 980 millibars or lower, you're getting into the realm of stronger storms. And so this particular storm sent a band of very intense snow with snowfall rates as high as 3 to 5 inches per hour. And so as the day progressed, you had very heavy snow. As you can see later in the day, that the snow band essentially pivoted across parts of the Adirondacks and far northeastern New York. And so you wound up with snow totals in excess of 30 inches across parts of the Adirondack. And if you can squint really hard, I'm even having to squint to look at this number right here. That's 42 inches here at Whiteface. So this will probably stand as one of the biggest storms in our record books for quite some time. And so this is the kind of setup. This is what we're looking for when we see large storms like this. any particular indications from things like radar, satellite that help us indicate the intensity of the storm, the moisture that it's tracking up in terms of the intensity of what we see on radar, as well as structure. A lot of us, when we're looking at these high intensity storms, we pick out the structures that jump out to us and determine whether or not we see those features again in providing future forecasts. And so a lot of times these type of events are really helpful in communicating to you, because most people remember when they get 3 to 4 feet of snow. I think one of the more recent examples, like the flooding in the Vermont side, I know New York wasn't affected as much by the flooding last July, but when we were communicating to the state of Vermont the idea of this flooding is going to be bad, we kind of said this will be as bad probably as Irene in this situation. And so maybe in the future, if you hear us say something like this might be as bad as the Pi Day storm, that may be something from us saying we're seeing signals that are similar to this that tell us that we're in for another doozy. So climatology and ingredients play a big part in our weather forecast. Probably one of the most popular methods of forecasting is an ingredients-based method. So you look for, do I have enough moisture? Do I have, what's my high and low pressure looking like? Do I have warm air coming up, or do I have cold air coming in? There's often a lot that's at play in determining what ingredients are present for different types of weather patterns. And so this particular example of climatology and the ingredients of a downslope wind event are to highlight some of those features. If anyone lives more on some of the northern facing slopes here of the Adirondacks, I'm sure you're very accustomed to dealing with southerly downslope wind gusts when we get into the fall season. And so these can be tricky because oftentimes we're having to look at the good old-fashioned thermodynamics, where we're trying to figure out whether or not the atmospheric conditions will allow for winds to reach down to the surface. And often an inversion layer, which is an area of air that is warmer than the air below it, will be something that helps to stabilize the atmosphere. However, if that inversion layer is right around ridge tops, winds can still get over that summit layer, and then they quickly rush downslope in that unstable area. And they're also compressed by the fact that they're riding up and over the mountain. And so as a result, often the Green Mountains, the southeast wind direction is often troublesome. Here in this Adirondacks, it's a little more south to southwest. That's a little more troublesome in providing downslope damaging winds. As I mentioned, sometimes we'll deal with these situations where we have lulls in between events, and often downslope winds result in drying in the atmosphere. And so sometimes downslope wind events will result in a brief lull in precipitation as well. So I think one of the primary examples for this area is Malone. The area of Malone often gets very strong wind gusts. And sometimes on radar, you can see the downslope clearing on radar appear as strong gusty winds develop downslope. And so as we start transitioning off of summer and getting into fall, we'll be in that realm of that potential for wind gusts greater than 45 miles per hour, especially ramping up as we head into September and October. And usually our peak windy season is in November. You'll see that there is a little bit of a secondary peak towards the spring months. And so a lot of the temperature contrast that happens is, so we have the Earth's tilt, and as we're rounding the sun, of course, the different hemispheres are receiving a different amount of radiation. And so as a result, you have a greater thermal contrast in the region during the winter months than you do the summer months. And so as we transition into winter, that contrast is what helps to drive the season of increasing winds. So climatology helps to describe a lot of the ingredients when we expect things to normally take place. And we do a lot of local research to be able to look at those things. And so from that, we use things like the weather models. We use our understanding of climatology and the ingredients present to then provide a forecast to the general public. So in the case where this is looking at one of the more extreme downslope cases in December 23rd in 2022, we'll describe, okay, like we're going to focus on the gusts themselves are very impressive. I mean, 65 miles per hour. I mean, there's a 70 mile per hour there in Malone. Like that's borderline hurricane force. But the idea of what exactly does that impressive number mean is something that we have to communicate. The idea that, all right, we're going to be dealing with down trees and power lines that could be numerous or widespread that may have a slow community recovery. And what makes things more complex in the forecast message is when we're having to deal with multiple threats at once. So almost immediately after these strong wind gusts, you then had a flash freeze take place immediately after. And there was a lot of rain that day as well. So you have recovery crews that may be wanting to go out and start their recovery efforts for their power lines. But then you also have a flash freeze that would then inhibit travel to and from areas to provide that recovery effort. And so sometimes our messaging is not just the exact winds, but also looking at the potential for other hazards to compound recovery efforts or create new vulnerabilities to communities that are trying to recover from significant weather events. And so oftentimes we'll highlight features like we'll plot hourly charts of the temperatures and what those look like to try and help decision makers find the point at which, all right, your roads are going to probably start freezing. Any water that's left over could be ice at that point. And of course, lake effect snow, the Adirondacks are no stranger to lake effect snow. Just to highlight here how these localized intense bands of heavy snow take place. They form over, especially when you can see on these satellite images that the lakes are ice-free and they're open for business. When you get a strong push of Arctic air over those very warm and frozen lakes, you can generate these long lines of lake effect snow in the right conditions. And they can extend well over 200 miles from Lake Ontario and Lake Erie. This was one of the more notable distances in a lake effect snow band that extended off of Lake Ontario and made it all the way almost over to the Canadian border. So that's it can extend very far. And of course, the Adirondacks has to pay attention to that heavy wet snow that can come from a lake effect event. And so proximity to the lake is a big thing. And then the wind direction over that lake are some of the ingredients that we're looking for when we're looking at these lake effect snow bands and whether they can persist. We want to see the wind kind of moving in the same direction so that they can follow this long channel and remain undisturbed. If they have any kind of south wind or north wind impinging on this lake effect band, it'll cause a little bit of turning and it'll disrupt it. So they're quite fragile. So to achieve something like this takes a lot of atmospheric work to take place. So we've now talked a little bit about our forecast process, how we look at climatology, and how we look at the ingredients and then communicate our weather forecast, often focusing less on the numbers, but more on what those numbers mean. So let's look at some details here on the website. I think there are a lot of aspects on the website that a lot of people aren't aware about. Sometimes there's things I even find in the website, and I've been using it for years. I think sometime last year, we received a call from a media partner who'd found some co-op and Cocoa Raws page that I had no clue existed. So there's a lot of information in here. You could probably spend at least 2 or 3 hours finding all kinds of different pieces of information on this. We have forecast by town, zip code, and a user selectable map. Anytime you click on our point and click map, takes you to a URL that is specific to that point that you click or select. So if you have a specific point that you're interested in and use it often, bookmark that page because that URL is specific to that point. So you can come back and refer to that on a consistent basis without having to try to find it over and over again. So we also, of course, have all of our current alerts. There are observations that you can find, satellite and radar resources. Of course, we've highlighted our rec and mountain pages. You can find a lot of this by these nice icons that kind of relate to some of the different products that we have, as well as some of the climate maps. Some of the office research that we do is also stored here. And I think a lot of people, especially that are more into the science aspects of things, or kind of why things played out the way things played out after the event, we'll often do write-ups of these significant weather events. There are also safety tips, and of course, we have the connections to our social media pages there as well. Our winter page has been nicely revamped, partly thanks to the efforts of Connor, who will often come and kind of do things with Whiteface ASCR. And so we have the potential snowfall as far as the general expected snowfall that we provide. But we also usually want to highlight forecast ranges and possibility. So there's a 10th% or the high amount of the snow forecast that's possible, and also a low end amount that you're going to exceed 90% of the time in a perfect forecast world. So you can use this information to give you an idea of some of the forecast uncertainty. If you notice that the gap is really large, you can say, okay, there's a lot at play in this forecast. There's a lot of uncertainty that's playing into this. Maybe I wait and see a little bit about how the forecast evolves, see what the trends are, make sure to check back in before I lock in on one decision. However, if the values are close, you can start to feel more confident that, okay, the 90% chance of receiving this much snow and the 10% chance of receiving this much snow are only a couple inches apart. You can feel a little bit more confident that what is being produced doesn't have a lot of model range, that we generally feel very good about how the forecast is going to play out. And as you can see, there are all kinds of different tabs. And so if you visit our webpage, you can click through each of these different tabs, and you can find more specific information about the forecasts based on that. And so we have the deterministic, the most likely scenario that as forecasters we anticipate. But we also do try and show the range of possibilities simply to communicate those uncertainties. In fact, I've already mentioned those points here, so we'll go on and head to the next slide here. One of the tabs that you can select on here is the 6-hour snowfall rates. We technically bin all of our snowfall forecasts in 6-hour intervals. And so you can also see from this about when the heaviest snow is going to take place by taking a look at these 6-hour snapshots. And so you can get an idea then from, all right, what's the approximate beginning of the snowfall event? When is it going to be heaviest? And when is the storm going to start wrapping up? Now, of course, 6 hours can sometimes, there's a lot that can happen in that 6-hour event, like the Pi Day storm, how snowfall was falling in the order of 3 to 5 inches of snow per hour. In that case, a 6-hour interval may not always catch some of those specific details, but it is a useful way to try and get from a planning perspective when things are most significant. There's not just snowfall in there. There's also information on wind chill. So especially if you're going out skiing and need to figure out how much you want to bundle up or how much wind you might be facing on the mountain slopes, looking at the wind chill forecast may be a helpful page for you as well. Now, on the complete opposite side of the spectrum, we do have a relatively new heat page. This heat page is most relevant now that we're here in summer, provides information on current observations, the maximum temperature, heat index, wet bulb globe temperature, and as well has heat safety tips. So whenever a heat headline is in effect, it's a little more uncommon here in the Adirondacks, thanks to the higher elevation. Usually tend to stay out of the hottest air masses. But if ever you're receiving heat alerts from that, we issue those whenever heat indices start creeping up towards 95 to 104 Fahrenheit. and excessive heat warnings when we start getting heat indices in excess of about 105. And so we have each of these different maps mainly to highlight through color coding generally the populations that are most likely to be affected and who is the most at threat for those hazards. So just some of the details. There's the heat index chart that you can find there on the page. And that kind of gives you an idea of how much strenuous outdoor activity or how much your body can take for how long in those heat conditions. And of course, the human body does acclimate to heat. And so oftentimes you'll hear us message things more intensely early in the summer season. So like when we had that early heat in June, that's a little bit early for our area of the world. Though our temperatures were not as record-breaking or record-shattering as they could have been, just the fact that it was so warm and humid so early before we had a chance to acclimate, and the Adirondack Airport over in Saranac Lake had just recorded a record low the day before. That kind of context makes a big difference. And so things like we'll often adjust the messaging when we start having heat outside climatological norms. For active hikers, things like the wet bulb globe temperature can be more helpful. This formed as a result of military agencies and OSHA recognizing that heat indexes were maybe not always the best measure for any of their exercises. So if you're more active, sometimes the wet bulb globe temperature can be an alternative measure to help you understand the risks of heat for more of those high-end activities. And we don't usually communicate things like the wet bulb globe temperature to the general public because a lot of people get confused because the numbers tend to be lower than the high temperature. And so that often confuses people. And so that's why it's kind of color coded to show when the impacts are most likely. And so some of the differences between wet bulb globe and heat is that wet bulb globe is measured in the sun. The heat index actually is not a measure that's intended to be taken in full sun. The heat index was actually based off of like these very specific parameters. Like it kind of follows the line of like average adult male, 5'7" feet, average weight, average sunshade, whatever. There's a lot of parameters that go into it. And so heat index is very complex, and so it avoids sunlight and sticks to mostly shaded information. And it does not take into account wind or cloud cover or the sun angle, which can play just as big of a role in your threat to heat, which the wet bulb globe temperature does. So if ever you're looking for an alternative to the heat index for your needs, give the wet bulb globe temperature a shot. We have IDSS forecast points, impact-based decision support forecast points. So our hourly weather charts that you can find on our point and click, they are not up to modern standards of general website appearance. They are not pretty to look at. They function well. They give you the forecast in an hourly point, but this is a little newer. It's still mostly in the experiment. I don't know if it's out of experimental purgatory yet. I don't think it is. So, but you can actually access this already. You can look at weather.gov/forecast points, and it brings it into something that's a little more sleek and modern compared to our hourly weather charts. And I think it just boxes a lot of the same information into a little bit more of a convenient way. So if you have been using our hourly weather charts already, and you've decided like this is a lot to look at or it's really difficult, try giving these IDSS forecast points. Give them a shot. All right. This was, I think, for a classroom setting in which we expected more of the general questions. So let's go briefly over this. Let's talk about submitting reports to the National Weather Service in Burlington. We issue a lot of advisories for heat, for snow, for wind, for all kinds of different things. We have different kinds of headlines. And a lot of times, especially here in the Adirondack wilderness, sometimes there's not a lot that we understand about what exactly is going on. There are a lot of microclimates here. I recently was visiting over at the I just blanked on the school name that's there in Franklin. Paul Smith's, thank you. I was recently visiting over Paul Smith's, and one of the people there was like, "Yeah, you never forecast the conditions here in this swampy area. You always forecast it too warm. It's always much colder." So submitting reports to the National Weather Service is one of the ways in which we learn about what's happening in your neck of the woods, and it helps us better map the terrain and the microclimates here in northern New York. If you ever want to submit reports, there's weather.gov/BTV/storm report. That's one of the best ways that you can reach us. You can also reach us on our public line. We're always happy to answer your phone calls. And then we also answer on social media via Facebook and Twitter/X as well. So this helps us create maps like this. We could not do it without your reports. And a lot of times when we're dealing with freezing rain or elevation dependent snow, we're often a little sad when we only get 1 or 2 reports out in the Adirondack wilderness. I can't stress that much enough how much we appreciate when we do get reports here in the mountain ranges, just because it helps map out the specific terrain features so much. The general public plays such a large part in helping us understand and create a full picture when we do our storm reports and write-ups. It really goes a long way to helping us fully understand what just happened. So now with that, let's get a little bit of a outlook here as we're starting to run into the fall and into the winter. Give you an idea of some of the climatology and what you have to look forward to this upcoming season. One of the big things is we're transitioning from El Nino into La Nina. It's one of the big drivers for climate. However, in our area of the world, it's one of those tricky things. It can go a lot of different ways. It means a lot more for the Great Lakes region than it does for us. But what typically happens is it usually kind of moves when exactly the season is. Oftentimes, La Nina winters, they kind of start early, but also end early. El Nino type events tend to start late. Actually, no, I've reversed it. Sorry,
Yeah.
I've reversed it. Sorry. La Nina events tend to start late and also end late. And El Nino events tend to start early, but they also tend to end a little bit early as well. And so as we transition into a La Nina pattern, really, it doesn't bear too much of a significant impact on us. One of the big things that we focus on are things like Greenland blocking. Is there a big area of high pressure over the Greenland area of Greenland, and whether or not storms can move past that block are one of the bigger things. During the September to November timeframe, generally Lake Placid's this is a 3-month average, by the way. Typically, you're going to average in that fall's time span about 55.8 degrees. And you're still not usually going to be below freezing for this fall season. In general, fall is a month with plenty of precipitation, with about 11 inches. And that you start getting snow, especially into October and November. That's when snow starts to gradually make that ramp up, such that you get about 12.2 inches here in like Lake Placid, Whiteface, Saranac Lake kind of area. This was the best climate site that we could kind of, I think, choose for this. The December-February climate, of course, you're more often than not going to end the month with your average temperature for the highs below freezing and borderline single digits across the 3-month time span. A little less precipitation. Warm air generally means more water vapor, and so cold air usually means less water vapor, less precipitation. But of course, with it being colder, this is the primary time for snow with about 68 inches. And as we again move into La Nina, usually that that favors above normal precipitation in the north coast of Alaska and the Pacific Northwest. But as you can see, whether or not stuff shifts east from the Great Lakes, often it just depends exactly on where does the low track. Answering that question of where is it going and what will it do will often make a larger impact. Generally, in these mountain areas, as you can see, the mountain summits are generally going to have a little bit more snow. There's Marcy there in this nice deep dark purple, indicating values of over 200 inches of snow. Here over more towards Whiteface, typically more in the realm of 125 to 150. Mount Marcy is just a little bit better located relative to the best wind fetch that you can get off of Lake Ontario for lake effect snow. Also being a little further south means you're also a little bit more likely to get more of the impact out of nor'easters, whereas even just that small distance north saves Whiteface Mountain from receiving the brunt of snow compared to Mount Marcy. And then, of course, finally, the elevation helps when it's an elevation-dependent snow to help Marcy eke out just a little bit more. And as you can see, some of the Vermont mountain slopes, especially with large southeast flow, runs upslope, but then sometimes it runs downslope across the Champlain Valley and doesn't always build steam up again as it runs upslope into the Adirondacks. And so, as you can see, the Adirondacks generally receives more snow than the Champlain Valley, partly from features like downslope winds. Any southwest winds will come downslope of the Champlain Valley and generally saves us in the Burlington area from receiving any of that lake effect snow. And our areas in the St. Lawrence Valley are well removed such that they don't get as much of an impact out of nor'easters. Here I picked Saranac Lake for what the coldest temperatures typically are on average. Your average high temperatures in the Saranac Lake area in the heart of winter in January, typically topping out in the mid-20s and near zero across the Saranac Lake area. Especially if there's a fresh snowpack that's fallen and then your skies start to clear out. There's a lot of dry air in place, and so all that snow just starts to sublimate into the atmosphere, takes a lot of heat out in the environment, and we see Saranac Lake just sink like a rock in temperature on those nights. And so Saranac Lake easily takes the cake of our coldest spot in the region for just how much of a unique terrain feature that it is. So here's a look at the average temperature. As you can see, maybe not so well, maybe a little small, but just the mean temperature across the months of September through November. You do start to, on your means, get to about 45 inches per the climatology from 1991 to 2020. And in general, receive about 10 to 13 inches of rain. And so our seasonal outlook kind of plays along the idea of with it, not a lot usually changes from the previous year to the next year. Oftentimes we talk about what's the best analog for this year. A lot of times it's the previous year because usually weather patterns change very slowly. They take a lot of time to adjust. And so given that the vast majority of recent winters have been above average, it is statistically safe to suggest that we will have another above average fall season. The precipitation in September and November largely depends on low tracks and features. There's no clear signal at this time how this fall will go in terms of wet or dry. Generally, equal chances are probably the safest bet. In terms of the December-February timeframe, your mean temperature is solidly below freezing. And so we build up the snowpack slowly but surely. And so you generally are getting a little bit less in terms of precipitation, but in general, about 60 plus inches of that snow working its way into that for about anywhere between 8 and 10 inches of liquid. And so generally, again, the statistical safe bet is that it'll probably be another above average winter in terms of temperature. This is a 40 to 50%. So fairly confident that it leans above average, but not quite as confident as, say, like the Texas region. And then, as we mentioned, El Nino, La Nina doesn't always mean very much for us. It's a bigger deal for the signal here in the Great Lakes region. The big question is, will lows track in such a way that we get a lot of snow out of the Great Lakes, or can they ride up in such a way that we can still benefit from some of those moisture sources? Or will we be largely devoid of any significant weather patterns and have to rely solely on lake effect snow to build those different, to build up our snowpack as we go throughout this year? So we have the climate forecast here, but a lot of times these are broad brush things. Like, these are over 3-month time spans. They're not going to tell you the specific, all right, you're going to have 2 events where you get massive snow. They're not going to tell you those type of features. They're just going to give you a general idea over the 3 months that kind of slates through and says, all right, in general, most of your days are probably going to run above normal, but it may not tell you that there could be a significant cold snap. It's still important to be prepared for cold snaps embedded in our warm winters, as well as considering that even though we may have above normal winters, that may mean that we just have to deal with more heavy, wet snow where we're dealing with temperatures that are 33 or 34, and as a result are dealing with more loading on trees just due to how sticky and wet that melting snow often is. And so with that, that provides an overview of why reporting to us is important and gives you a little bit of an overlook of what you may have to look forward to this fall and winter. And so before we hop into the questions, I always like to say thank you for attending. We have plenty of resources. We have the winter page that we highlighted, the heat page that we highlighted here, as well as all of the resources on our main page. You're welcome to call us. We are available 24/7. So take that for what it means. So thanks, everyone.